All right. Well, this is the mini lecture for non-experimental research, which includes observational methods, correlational methods, qualitative, and also quasi-experimental. So we'll be kind of jumping around a little bit here, just because some sections are a little bit more lengthy than others. So first and foremost, what does non-experimental research actually means? And your textbook defines it as research that's lacking manipulation of an independent variable, random assignment of participants, or both. So those are really hallmark examples of a true experiment. Now, many times you will hear the term experiment get loosely used to explain a study. And so do your best not to kind of equate those two. Um, Researchers will do studies all the time, and studies can be correlational studies, observational studies. But when we use the term experiment, that does have extra weight behind it. That does mean that the expectation is that you have an independent variable that you truly can manipulate, and you have randomly assigned participants to different conditions. So when those are not able to be met, it is going to fall under a non-experimental typology. So here it just kind of goes over some examples, which are kind of answered later on, but it kind of sets up a nice overview for the mini lecture. So research question or hypothesis can be about a single variable rather than a statistical relationship between two variables. So this is, if you just have a single variable of interest, then yes, it's going to be a non-experiment. Research question be about a non-causal statistic relationship between variables. So again, ideally with an experiment, you're getting at a causal relationship. What causes this to happen? If your research question is much more just about frequency, for instance, then yeah, it's not going to be listed as an experiment. And again, that's not necessarily a bad thing. It's just making sure that you understand what it is you're going to be doing with this question. Research question is about a causal relationship, but the independent variable cannot be manipulated or participants cannot be randomly assigned. Excuse me. So the example that they use here is great. Does damage to a person's hippocampus impair the formation of long-term memory traces? So as a researcher, ethically, we cannot go around and damage people's brains to see what impact it has. We can take people that already have had brain damage done to them, right, due to accidents or medical procedures that was decided we're going to do this to try to assist somebody, whatever the reason might be. But that means you can't randomly assign people to the group that has brain damage versus the group that doesn't, right? Because they already have it. You have no control over that. So that's where the term quasi-experiment will come into play. Research question can be broad and exploratory, or it can be about whatever it is like to have a particular experience. So again, nothing wrong with those type of questions. It's just not going to fall under the heading of experiment because you don't have means of manipulation. So instead, this would be more so like a qualitative study that you are doing investigative work, trying to answer a big question. You're just going about it through surveys and interviews instead of going about it through manipulation of variables. So it goes into some detail here about single variable research and whatnot, but we're going to highlight all these actually coming up. Those are just kind of the main talking points of this whole chapter. And I did want to highlight this just because I thought it was a really nice graphical representation. So we talked about validity already in an earlier mini lecture. Internal validity, again, is just how much control do you actually have in your experiment. And you can see correlation and quasi-experiment, you're on the lower end. Experimental, you're on the higher end. Because again, with an experiment, you get to have full-on control of everything that's happening. Whereas correlation or quasi, you're losing control just by the nature of that design. Again, not saying it's a bad design, just want to make sure that it's crystal clear that we can still gain valuable information and valuable resources through these types of designs. It just is not the same as an experiment. And sometimes it doesn't need to be the same. So we'll look at then correlational research first. So correlation is the idea that you have two variables that are related in some way to one another. When we look at a correlational research design, reasons why people will go about kind of doing this type of design is that they do not believe statistical relationship is a causal one. So again, you have two variables of interest. You ultimately don't think one is causing the other. You just want to see how do they relate to one another. So it goes over a little bit of a psychometric thing of using two different scales, and if they correlate, you can know that, all right, each scale was essentially measuring the same thing. The other one is the second reason is the more interesting one in my mind, is that you have statistical relationship of interest is thought to be causal, but the researcher cannot manipulate the independent variable because it's impossible, impractical, or unethical. So we in psychology study wide range of behaviors, some of which are detrimental or antisocial. So you can't really get at that component. One of the big things that I typically run into with the forensic psych side of things is students who are, excuse me, students who are very interested in, mass murderers, serial killers, stuff like that. And they want to set up a study to figure out why does this happen? And it is a totally fine research question. Why does a serial killer kill? But how to actually set that up with an experiment is impossible, right? Because we can't randomly assign people to be serial killers. We can't randomly, assign people to be victims and, ask them to do different things to see if that makes them more or less likely to be a victim. We can't do any of that stuff, and rightfully so. So instead, we can do correlational studies to look at, do these factors seem to have any type of relationship on what it is that we see? So, sending surveys to those that are incarcerated about childhood development, about stress management, about any type of medical history, and we can start to build these cases that there does seem to be a relationship between, this event happening in childhood and you being more likely to become a serial killer. But again, we would never say that because this happened in somebody's childhood that made them a serial killer. We will never be able to get to that point using, well, just ethically, never get to that point because it's always going to be correlation at best. This chunk is just kind of nice, and I purposely highlight it because this is what you will see a lot in just news reports about research, and they will get it wrong and they will misrepresent what that actually is saying. So here we have this is a hypothetical chart that says daily to-do list, yes, no, and then the level of stress. And based on the chart, it looks like if you have a daily to-do list, your stress levels are less than if you do not have that list. And again, on the surface, that seems fine, but if you were to ever see this on the news, they would say those that create daily to-do lists ultimately experience less stress. So the suggestion would be to develop these lists. But we need to understand how is that data actually collected. And so that's what the chunk highlighted focuses on. So if the researcher randomly assigns some participants to make daily to-do lists and others not to, then it is an experiment, right? And then yes, we would be able to say, based upon the study, it does appear if you make daily to-do lists, you experience less stress. However, if the researcher simply asked participants whether they made daily to-do lists, then it's a correlational study. And that distinction is important because an experiment could be concluded that making the list actually reduces stress. By correlation, it can only be concluded that these variables are statistically related. And this is where we get into directionality and third variable problems. So Perhaps being stressed has a negative effect on people's ability to plan ahead. So then it's not that making lists makes people less stressed. It's actually that those that are less stressed have the foresight to make lists in advance. Or perhaps people who are more conscientious are more likely to make to-do lists and less likely to be stressed. And there you have a third variable. It has nothing to do with the list. It has more so to do with personality. And so again, understanding that when you show an image like this, it's going to be taken in a wide variety of ways. You need to understand what's the story behind it, because the way they conducted the study will greatly differ what this chart is actually showing us. So naturalistic observation, so observing people's behaviors and environment in which it typically occurs. So it's also known as field research, that you go out and you just kind of observe people doing things that you are interested in. So this study that's highlighted in this section of the book talks about walking speed based upon countries, and it does look like, the country of origin does impact how fast people walk. So in US and Japan, people walked about 60 feet in 12 seconds, whereas Brazil and Romania took 17 seconds. And it lets us understand, like, okay, maybe there's more time-oriented priorities in US and Japan as opposed to Brazil and Romania, right? We can draw some conclusions off of this. If it's right or not, we can't say that, right? Like, observation just allows us to get counts, allows us to get data, but it doesn't allow us to look at causal, and we can only do that in an experiment. So precise specification of sampling process in this way makes data collection manageable for the observers, and it also provides some control over important extraneous variables. And this is everything that they were considering when they did this walking study. So they wanted to look at main downtown areas in every city. Measurements were taken during main business hours on clear summer days. All locations were flat, unobstructed, had broad sidewalks, and were sufficiently uncrowded to allow pedestrians to walk at their potentially maximum speeds. To control for the effects of socializing, only pedestrians walking alone were used. Children, individuals who had obvious physical handicaps, and window shoppers were not timed. 35 men, 35 women were timed in most cities. So that is a very clear distinction of what it is that the researchers were looking for and not looking for, right? So if you saw anybody that was with somebody else, or if you saw a child, you could not start the timer. You had to look for somebody who, was by themselves and got into the zone that you caught when right before they entered the zone, and then you were able to watch them all the way through. They also talk about a bowling expression study, which is kind of fun in the textbook, but again, having very clear distinctions of what it is that you are looking for. And we call that coding. Coding requires clearly defining a set of target behaviors. So what exactly is it that you're looking for in this, so that everybody who's helping with the study can clearly observe what it is that they're supposed to be observing. Even with really good coding, there's still going to be errors that happen. I mean, humans make mistakes, but certainly we can try to limit those if we actually do coding with our studies and have norming sessions and things like that, to where hopefully all of our observers are on the same page. Archival data. So this is essentially data that was collected for some other purpose that you were able to get your hands on, and now you can go analyze and figure out if there's anything of interest. There was a study that looked at Social Security records, show that women with names Virginia, Georgia, Louise, and Florence were more likely to move to states of Virginia, Georgia, Louisiana, and Florida, respectively. Right? Does it mean anything? Who knows? The author titled it Implicit Egotism. So the idea that because your name is that of a state, you're going to seek out that state. But we can't say that for any certainty. It could just be the other way as well, right? That if you're born into these states, your parents are just more likely to name you those. Again, we can't talk about anything to do with their egotism because it might be parental, but it's just an interesting study to think about for archival data. Sorry, I'm kind of jumping around there. So then we get into quasi experiments. So quasi, what that prefix means is resembling. So quasi-experimental research is research that resembles experimental research, but it's not a true experiment. What that typically means is that you can't randomly assign people to conditions. It's typically using a subject variable, so something like sex or race, for instance. I can't have a participant come into a study and then tell them, I'm going to make you this race when it's not theirs, right? They are bringing that in. It could also be personal experiences. So a lot of research on trauma, we obviously can't traumatize our participants. It's unethical. So we will seek out individuals who have experienced trauma, but again, we are then doing it quasi because we're going to have a group that has experienced trauma versus a group that hasn't. But we didn't design that or randomly assign people to it. They're bringing it in themselves. So non-equivalent groups design is a between subjects design in which participants have not been randomly assigned to conditions. So between subjects, that ultimately means that you're only exposed to one level of the experiment. If it's within subjects, it means that you are exposed to all different levels. So just to kind of highlight this, and it will be in other mini lectures as well, if I had 3 different drugs that I was trying for pain relief, I can do a between subjects that my participants only get 1 drug, and then I measure to see how much reduction did they experience. The downside to doing between subjects is that you do need more participants. The upside is that you can be sure that it's only that drug in their system or only that drug that they've actually taken. A within subject design would mean that all participants got all 3 drugs just at different times. So they got exposure to all of them. The good side is that we don't need as many people. It also would let us see individual differences between each drug, and if we can find any pattern. The downside is that we run into practice effects for something that is actually active. So you just get better at doing something the more exposure you have to it. That's what a practice effect is. For the drug, you have just kind of time, right? That if you have them take these drugs over a 3-week period, the symptoms are probably decreasing just naturally as well. So there's give and take there. Non-equivalent group design, then participants have not been randomly assigned to conditions. The example your textbook uses is that if you have 2 third-grade classes and you want to do one class, ultimately, I'm trying to think of what it is that they're trying to do. Oh, different methods of teaching fractions. So you want to try a new teaching method with one class and keep the other class at the old teaching method. It's non-equivalent group design because you aren't controlling for the assignment, right? They're already placed into groups. You're just taking the already established groups and saying, all right, I'm going to do this. But there could be different reasons students are in the different groups. There could be different teaching methods that have already been established in each group. There's a lot of side things that could also be kind of confounding your study. Pre-test, post-test. This one is probably the one most people are familiar with. It's the idea that you are given some type of test or measurement before a treatment, and then you're given it afterwards. In the academic realm, many instructors will do a pre-post test that, first or second day of class, they give you a pre-test to see how much material do you actually know right now. And then at the end of class, they'll give you a post-test to see how much have you learned since the class started or that day or whatever it happens to be, right? So the idea is that the treatment, as your textbook lists it, is the instruction, right? That whether it's for a semester class, quarter class, or just a unit or a week or a day, whatever it is, it's the idea that the instructor is teaching something. That's the treatment, and ideally, your post-test is improved from what your pre-test was. We also have something known as regression to the mean, which this is a statistical tendency, but it's the idea that if you score very well or very poorly on something and you were asked to take that test again, odds are you're going to ultimately get closer to what the average is. So let's just say you take a math test and you bomb it, and then you're ultimately offered to take it again. Odds are you're going to improve. And so we run into these concerns for people that have extreme scores, and that's how we're using them to split up the groups. Your textbook uses the example of a bowler, that if your average is 150 and you bowl at 220, you can almost guarantee that you're going to do worse the next game. You're probably not going to get 225 the next game. You're probably going to get like a 140 the next game, right? You're going to get closer to what your average is. And same thing goes with a lot of different tests, that if you consider yourself to be average in math and you have a really good test, your next test is likely to go down because it's going to get closer to the mean. And then we have interrupted time series design. So this is a variant of pre-test, post-test. Ultimately, the pre-test, post-test, there's issues that arise from it. And there's issues with every single design. The interrupted time series tries to fix one of those issues. And pre-test, post-test, the issue is, even if you're not retaining information, or even if the treatment is not really working that well, just time has happened, right? So let's say somebody goes into therapy, they enter depression, and so they start having these therapy sessions. We like to think that the therapy session is working, that when they first entered, they had scored very high on a depression scale, and after 6 months of therapy, they're scoring pretty low. But is it the therapy that's really doing it, or is it just simply time? That a bad breakup, over time they got better, death in the family, over time they got better, and therapy is just kind of there. It's not actually doing anything. We can't say. We'd like to think it's the therapy, but we don't know for sure. So interrupted time series tries to address that it's ultimately you take measurements at different intervals over a period of time, and the interrupted part is you introduce the treatment. So again, whatever that means, we typically think of treatment in the medical terms, but it can be anything of interest. So one example here is treatment in a company was to reduce work shifts from 10 hours to 8 hours. And they want to see, does that actually make a difference long term? So it wasn't just they looked at production beforehand and then they're going to do the shift and then they're looking at the production afterward. They interrupted this series. So they said, we're going to evaluate it over the course of a year. And at some point in that year, we're going to switch it from 10 hours to 8 hours. And then we're going to see, does it impact anything? What they found here is that going to an 8-hour shift actually was very beneficial for everyone. But that's what the interrupted part means, is that it's interrupted by the treatment. You have your time listed out, but you're not doing treatment the whole time. And here's just different graphical representations of it. And then last bit, qualitative research. So your textbook goes over the fact that it primarily talks about quantitative research, and I will say that is my field as well. I have never done a full-on qualitative study. I've listened to people that have and tried to learn from them, but I've never actually done it. So everything that I've been trained in has been quantitative research. And so your textbook makes sure to note that, yes, the vast majority of this book is on quantitative research, not qualitative, because the authors of your book are quantitative researchers as well. But that does not, that shouldn't say that qualitative research is worthless. It is extremely valuable. It's just a matter of what it is that you're trying to answer and why you're trying to answer it. So ultimately, when we look at kind of the purpose of qualitative, so quantitative means that you typically get answers on some type of measure, number scale lines. You've turned responses into numbers and averages, and you run statistical analyses like what you've been doing in labs and will continue to do. Qualitative is more about having a conversation, that you're actually typically interviewing individuals and asking them questions and writing down their responses. And you're looking for patterns about how they're saying things, about how they're interacting with people. And based upon those, you're then developing, all right, here's what I'm seeing. So it can help researchers generate new and interesting research questions and hypotheses. So even though, like me personally, I've never actually done a full-on qualitative study, I do typically have some very minor qualitative components in my research for this reason of seeing, all right, why are people answering the way that they are? I can make my conclusions based upon, patterns that I see and statistical differences and all that stuff. But it's also nice to have them have a space that they can write out or that they can tell you, well, I made my decision because of these reasons, because that might open up new doors for research and things that I've never even considered, because they told me here's what it is, and now I can develop a new line of research. Qualitative research also provide rich and detailed descriptions of human behavior in the real world, and it's in the context that it actually occurs as well, which again can be extremely valuable to have. So it's really just kind of informing people about here's what is happening. So you can do this in a wide variety of ways. You can conduct an interview that the person knows, hey, I'm in a study, I'm going to ultimately do this interview, and you ask them very direct questions and you take notes on what they say. You can do it in focus groups, which is small groups of people that you just ask questions to the group itself, and maybe you write down the discussion or record the discussion so that we can transcribe it later. You can also do participant observation. This is where the researchers actually become active participants in the group or in the situation that they are studying. So they actually kind of become one, and then they can do a little bit less structured interviews, and it's just a little bit more fluid. People might be a little bit more open or honest if they view you as an in-group member instead of an out-group member. Let's see, method of data analysis that distinguishes more between quantitative and qualitative. That when you are looking at just an idea, it's very hard to just look at that by itself and say this is going to be qualitative or quantitative. It's typically, once you get the data, what is it that you plan to do with it, or how do you go about actually designing the study to get the data. And again, many times you're going to collect data that is both qualitative and quantitative. You might only be interested in one, but many researchers will collect both just to have a little backup plan, or maybe split it up into multiple studies. But you can certainly have mixed study designs, which you'll see in a little bit. But the data analysis part is the part that lets us know what type of research is this truly. There's something called grounded theory, which is kind of fun because it's the opposite of how, again, most of the time research is talked about. So quantitative research, typical for the researchers, start with a theory, derive a hypothesis, and then collect data to test it. In qualitative, if you're using grounded theory, you actually start with data and then develop a theory or interpretation that is grounded in that data. So you have an idea, right? I'm interested in this topic. I have no idea what to expect, so I'm just going to collect the data. Once I see it, I'm then going to try to develop a theory based upon it. With qualitative, you do run into external validity concerns, right? Like how well does this generalize out to others? Certainly is going to be there, especially with like a grounded theory, but you're going to run into external and internal validity concerns with just about anything. Again, it's just as long as you know that's what it is. So again, you can kind of cycle in and out depending on what you have available to you. And then mixed method design. So this is where your study actually has components of both quantitative and qualitative. Um, and there's nothing wrong with doing that. There were some debates a while ago, but for the most part, people are like, absolutely, if that's what you think is going to be the best approach, use both of them. It is a long process to do both, because you not only are doing the data analysis from the quantitative side and different statistical programs, you then are also transcribing and looking at patterns for the qualitative stuff. So it is just a very lengthy data analysis procedure. All right, and with that, that then ends this mini lecture on the non-experimental research stuff. So if you have any questions about any of it, please do not hesitate to let me know.